Good day to all of you. Thank you for listening in to our presentation. My name is Snijkers, and together with my colleague José Gómez Pires, I will do this presentation. We both are working at the Methodology Department of Statistics Netherlands in Ireland. We will discuss exploring precision farming data, a variable new source for official statistics. And we will answer this question, but to a large extent we will discuss a pilot with system-to-system data communication applied to John Deere data. Here we'd like to express our gratitude to John Deere for offering this opportunity. Before going into this pilot, let's first discuss the idea behind system-to-system data communication. For the production of official statistics at Statistics Netherlands, we mainly use electronic questionnaires and registers. A side effect, however, of the use of questionnaires is response burden, which businesses obviously do not like. Now, when looking at developments in the business world, and for our case, look at developments at farms, we see a growing use of new sensor-based technologies like smart farming. And because of this, nowadays farmers even tell us, why do I still have to complete this questionnaire manually? So the question is, how can we use these data as input for official statistics and pre-fill questionnaires, thus reducing the workload for businesses? In this presentation, we will discuss a pilot with John Deere as a first proof of concept. Having this idea in mind, in 2019 we started exploring data sources in the agricultural sector. First, we explored data from one farmer who is using smart farming technology. Also, we checked data that are available in farm management systems. In the Netherlands, we have two large systems called DACOM and Agrovision. And at the beginning of this year, 2020, we discussed our idea with large manufacturers of agricultural machines. And it turned out that they had started a project called Atlas, aimed at achieving interoperability between their systems. The conclusion of these data explorations is that there are still many challenges if we are to use these data as one, let's say, big data source. I will not go into details here because of the time, but these challenges include getting access to the data because of trust or money issues, the quality of the data themselves, like missing metadata and missing data items. In order to get representativeness, the general use of these systems is still limited, as well as is the interoperability between these systems. And this also relates to data harmonization, to make sure that the same data are defined in the same way. And finally, as input for official statistics, stable delivery of the data in the future needs to be guaranteed. From these data explorations, we concluded that these data sources are a valuable and promising new data source for official statistics, but we still have a long way to go. However, instead of looking at the data from a population perspective, we thought about its usability at the farmer's level. How can we use the data available in one farm to complete questionnaires? In order to explore this, John Deere offered their support. They offered access to data in the MyJohn Deere playground. So, as we have seen, our goal is to get the same data as we get when using questionnaires, and at the same time reduce response burden as much as we can by pre-filling the electronic questionnaires. Our solution to this problem is system-to-system data communication, and José will explain how this works in a minute. Internally, we discussed a pilot with a questionnaire to apply this method. We decided for the crop yield survey questionnaire, which is sent to a sample of farmers at the end of each year. Farmers have to report the expected yields of a number of crops like wheat, barley, rye, corn, and potatoes. Next, we explored the data in MyJohn Deere, and it turned out that the questionnaire can be almost for 100% be pre-filled using these MyJohn Deere data. In addition, we'd like to say that the John Deere database includes many more data that could be used as input for statistics, like machine data and data about the soil and environmental conditions. We'll come back to this at the end of our presentation, but first José will explain the system-to-system data communication. José, the floor is yours.
Thank you, Hen. I will continue from here. This slide describes the process sequence. We are assuming no ambiguities because they will be explained in a later slide. We have chosen a microservice architecture. The first step is the online questionnaire. The farmer logins using his user and password, as usual. The farmer is asked if he has John Deere smart farming machines, if he uses the MyJohn Deere service, and if he is willing to use the precision farming data in order to prefill the questionnaire. In case the answer is yes, we get the temporary and partial access. This is done without sharing the farmer credentials. This authentication protocol is powered by the OAuth standard. Via the microservice application programming interface API, the microservice browses the John Deere cloud, collecting the data that we need via the MyJohn Deere API. They are temporarily kept in memory. Based on this data, the answers are calculated and imputed in the online questionnaire. The farmer can see and edit the questionnaire, and finally, the farmer decides whether or not to submit the answers. This is an example of the output that the microservice provides to the online crop yield questionnaire. It's shown in a beautified JSON format. In the first section, we find the information about this crop season per crop. Data quality indicators are provided. They will be discussed in a later slide. Sometimes it's not possible to classify crops as winter crops or summer crops. This will be discussed in a later slide. In the last section, we can see the answers about the next season. We use different software engineering concepts to assure data quality. Exceptions are errors at runtime. They can be caused by external factors, but a proper error handling allows the microservice to be fault tolerant. At the same time, we use the exception counting as data quality indicator. Automated integration and unit tests help us to guarantee the data processing quality. A detailed log allows audit trailing. In this slide, we have an example of ambiguities. It's not possible to know in the field 2 if wheat white is winter wheat or summer wheat because of the name wheat white and because we don't have seeding information. With this information, the online questionnaire can display a form and we can ask to the farmer for the type of crop, summer wheat or winter wheat. When the farmer submits the information, an asynchronous API call is made and the microservice receives the missing information. With this extra information that was missing, the microservice can recalculate the winter wheat section, because now we have new data that affects to the winter wheat totals. And the new totals can be displayed in the online questionnaire.
We have developed a production software for automatic crop yield data collection. We plan tests in 2020 and to go to production in 2021. In order to achieve this, a new system-to-system data collection methodology has been developed. It's applicable to many fields, but we need to satisfy three conditions. We need a significant overlap between the questionnaire and the data source. The data source should have an API, and is highly recommended an authentication protocol because of privacy reasons.
In this pilot, we focus on operations data, but there are a lot of kind of data in the John Deere Cloud, like machine data, agronomic service providers, activity data, soil data, environmental conditions. This is a huge potential data source for new statistics. Applying slight changes to the current methodology is possible to obtain a real-time system-to-system data collection tool. Thank you very much for your attention.